In our last video, we talked about MRP and what that means, what MRP is, and how we go about getting the different inputs and outputs of MRP processing. We talked about the product structure trees, assembly diagrams, bill of materials, and all of the inputs that are needed so that we can run MRP and give us the outputs that are necessary to help us run our business. MRP processing is a big piece of what is done after you load the master production schedule. So in this video, what we're going to discuss is the MRP processing using lot-for-lot ordering technique. We're going to also discuss about the MRP explosion process and talk about the lead time offset, which is important to understand when we're doing MRP processing. We're going to go over our first example using lot-for-lot in MRP processing. We'll do it together. So make sure that you've got a blank MRP matrix handy for this example. So what you see on the screen now is MRP processing that's offset by lead times. So when we have our bill of materials, our various inputs that go into MRP processing, one of the inputs is lead times. And lead times are how long it takes from the start of something being ordered or manufactured to when it is complete and has arrived and is ready to use. Lead times can vary anywhere from 1 week to 6 months to a year. It just depends on the type of item that you're buying. In this example, you can see that the lead time for this product, item A, is 8 weeks. And all of the various components that go into it, A, B, C, D, E, F, G, and all of the various letters there, they have different kinds of lead times. Some are 1 week, some are 2 weeks, some are 3 weeks. But if you look at the top of the product structure tree that's kind of flipped on its side here, you can see that item D, when you start production of it in week 4, it will be completed in week 5. But you can't start item B until you have both items D and E. So item E has a 2-week lead time, so you must start making it or you must buy it in week 3. So you make that item or you buy that item starting in week 3. It has a 2-week lead time, so it will arrive in week 5. Now that you have items D and E, you can start producing item B, and that takes 2 weeks to build. So you start in week 5 for subassembly B. It takes 2 weeks, and then it will be done on the 7th week because you started in week 5. To build item A, it takes 1 week, and you have to have the subassemblies B and C completed so that you can start building A. And A will take you 1 week, so after B and C have arrived, you can then start producing item A, and that takes you 1 week, so that will be your 8-week lead time. Now, if you're in manufacturing, one of the goals that you're trying to achieve is to reduce your overall product lead time. So just by looking at this product structure tree, you can determine, okay, item F has a 3-week lead time. Item G and item E, they've got 2-week lead times. So you would probably start there to see which of those lead times you could potentially reduce, maybe down by a week or so, to make this total lead time go from 8 weeks to 7 weeks or 6 weeks. So those are things you can do in manufacturing to try and shorten those product lead times. So MRP processing takes the end item requirements specified by the master schedule and explodes them into time phase requirements for assemblies, parts, and raw materials. And again, those bill of materials are offset by lead time. So what we're going to do later is we're going to work on processing just a couple items, and we're going to do it manually. But when you run MRP through the system, it will do this for thousands of components and thousands of lead times and thousands of items in inventory all at the same time. So MRP explosion. MRP explosion is the process of using the logic of dependent demand to calculate the quantity and the timing of orders for all subassemblies and components that go into and support the product of finished goods, or the production of finished goods. I always think it's kind of funny that we call the bill of materials the bomb, and with MRP, there's an explosion process. That's just manufacturing humor, I guess. But the bill of materials is the bomb, and then we do that. Then we do an MRP explosion so that all of the products, we know what to buy, when to buy it, and how many to buy. So there are 3 different kinds of lot sizes that are used in the MRP explosion. Lot sizing is the process of determining the appropriate amount and timing of ordering to reduce costs. So the first example for this video that we're going to go through right now is lot for lot. Lot for lot is an ordering schedule that covers the gross requirements for every week. So if you need 75, you make or you buy 75. If you need 57, you make or buy 57. You make or buy exactly what you need to cover your gross requirements. So your net requirements equal your gross requirements. A fixed order quantity uses a fixed order size for every order or production run. This could be considered an economic order quantity, or if you have to go buy something from a manufacturer and they don't let you buy exactly what you want. Let's say you need to make or buy 213 units of something, but your economic order quantity or your order quantity from the manufacturer is they only sell them in lots of 250. So even if you want to go buy 217 units, you have to buy 250. That would be a fixed order quantity. Those are very, very common. You will encounter them a lot, which is why we're going to go over lot for lot and fixed order quantity, because both of those are very common scenarios in the workplace. Periodic order quantity isn't as frequent, but this is when you order a quantity equal to the gross requirement quantity in one or more predetermined time periods minus the projected on-hand quantity of the previous time period. So you're going to be making these orders on a periodic basis, and you're going to be adjusting the quantity that is needed every time you do that periodic order. So MRP processing, I have changed this slide multiple times over the years that I've taught this course, and this time I added some color coding, so hopefully it makes a little bit more sense for you. The reason why this is so tricky, even though it's actually a quite simple concept, is because with MRP processing, we are just trying to net out and figure out what our net requirements are. That is the core of MRP processing. We want to find our net requirements. The gross requirements is important to know, but we need to take into consideration things like available inventory, projected on hand, safety stock, how many are coming in, how many are already there, how much of your inventory is already allocated to other projects. MRP, when we do that MRP explosion in the system, it will do that for us when we use an MRP system, but for sake of this course, in our blank MRP matrix, we can't go through all of those details. So I really encourage you to use the MRP sheet that I've provided for you because it matches up with what I'm going to go over here on this slide and the next few slides. So you can see why I've done some of the colors that I have. Net requirements, simply put, is your gross requirements minus your available inventory. Gross requirements equals your total expected demand. So gross requirements is just however many total that you need. Available inventory generally equals projected on-hand inventory minus your safety stock minus your inventory allocated to other items. But we're not going to go over all of that in this course. So for sake of the MRP matrix that we're going to do, projected on-hand equals projected on-hand inventory plus scheduled receipts. So again, projected on-hand equals what you have on hand plus what you have on order. That's a scheduled receipt. When you add up on hand plus on order, that's your projected on hand. And again, for this course, we will always assume that if something is expected to come in, that it will. So if you have 70 pieces on order in week 2, they will arrive in week 2. And then they will move from being a scheduled receipt to projected on hand inventory. Okay, once it goes from on order to received, then it gets into inventory. So what we want to keep in mind here is net requirements equals gross requirements minus projected on hand. Okay, let's go over this one more time. Gross requirements is your total demand for a product. Scheduled receipts is your on order, and that could be a make or a buy product. Okay, it could be a manufactured or a purchased product. So scheduled receipts is what you have on order. Projected on hand is product that's already in inventory and it's already sitting on hand. And then your net requirement is the remaining total to make or to buy. Again, the whole reason we do MRP processing is we don't want to calculate out the gross requirements. Gross requirements are necessary to understand, but we want to figure out our net requirements. There's no point in making or buying excess materials to support the gross requirement if we already have material on hand. So a very simple example is your gross requirements are 200. Your on order is 75. Your on hand is 35. So therefore your net requirements equal your gross requirements of 200 minus your on order of 75 minus your on order of 35 gives you a grand total of 90. That is your net requirements. So here is your MRP processing blank form. Again, this is provided to you on Canvas, and you can print copies for a couple copies so that we can walk through these together. So MRP processing. We've already pretty much gone through what most of these definitions mean, but gross requirements is your total expected demand. Scheduled receipts is your open orders scheduled to arrive. Projected on-hand inventory is the expected inventory at the beginning of each time period. And then net requirements is the actual amount needed in each time period. Now there's two other things to keep in mind for MRP processing. The very first slide I talked about the lead time offset. The lead time offset, and that's very important for MRP processing. And when we showed that product structure tree, you could see if something was offset by 2 weeks. Let's say you needed something in week 5, you had to start making it or buying it in week 3 if there was a 2-week lead time. Well, that's what we're going to calculate for every single item on this MRP processing sheet. Your planned order receipts are the quantity expected to be received at the beginning of the time period. Your planned order releases are the planned amount to order. In each time period, planned order receipts are offset by the lead time. So your releases are going to come before your receipts. I'll just use week 5 as an example again. If you need something in week 5 and it has a 2-week lead time, you must release the order to either be made or purchased in week 3 because it's offset by the 2-week lead time. Okay, so let's go through an example together. A firm produces wood shutters and bookcases, has received 2 orders for shutters, one for 100 shutters and one for 150 shutters. The 100-unit order is due for delivery at the start of week 4, and the 150-unit order is due for delivery at the start of week 8. Each shutter consists of 2 frames and 4 slated wood sections. The wood sections are made by the firm, and fabrication takes 1 week. The frames are ordered, and lead time is 2 weeks. Assembly of the shutters requires 1 week. There's a scheduled receipt of 70 wood sections, meaning at the beginning, of week 1. Determine the size and timing of planned order releases necessary to meet the delivery requirements under each of these conditions. Now you're only going to see one because I deleted B, which was lot sizes, which we will do in our next video together. But for this video, we're going to do lot for lot ordering only, which is where the order size is equal to the net requirements. Now, a couple things to keep in mind. First of all, this is a lot of words. So if you get an exam question like this, you're going to have to take everything that's here, write it down, and try and make sense of it, like you'll see on the next slide. And the second thing to keep in mind, and this is just something that you know to take with you as you go into your career, for MRP processing, it does not matter whether something is a make item or a buy item. MRP processes it exactly the same. So you can see in this example that some items are manufactured internally by the firm, and others are procured or purchased outside the firm. But MRP doesn't know the difference. It knows the difference in a purchase order and a work order, but they're both open orders, and they are both expected to arrive on time. They both follow the same lead time offset methodology. So MRP will run exactly the same for manufactured parts and purchased parts. So here's all the information for our example. Okay, let's write it out a different way. Up top, your order for your shutters. This is the summary of the information that was provided in the last slide. Your order for the shutters, you've got 100 shutters due in week 4. You've got 150 shutters due in week 8. Each shutter consists of 2 frames and 4 slated wood sections. So that's your product structure tree. Your shutter is level 0, and your frame and your wood are level 1. They are both necessary to build the shutter. You can't build the shutters without 2 frames and 4 wood sections. Wood sections are made by the firm, and they have a 1-week lead time. Frames are ordered, and they have a 2-week lead time. Assembly of the shutters is 1 week. There's a scheduled receipt of 70 wood sections in week 1. Do not overlook that fact. And then we are going to determine the size and timing of planned order releases necessary to meet the condition for lot for lot. So let's get your MRP sheet out, and let's work on this one together. So start with your blank MRP sheet. Next step, you're going to fill in your master schedule, which is 100 units of the shutters to ship in week 4 and 150 units of the shutter to ship in week 8. Next, we're going to fill out all the information that was given in the problem. So your shutters in the top quadrant there have a 1-week lead time, and they are lot for lot. Your frames have a 2-week lead time and are also lot for lot in this example, and they are 2 frames for every 1 shutter. The frames are dependent items of the shutter. Wood sections also have a 1-week lead time. We are doing an example that is lot for lot. There are 4 wood sections for every 1 shutter, and we have 70 scheduled receipts due to arrive in week 1. So this is all the information that was given to you in the example. Everything so far has been provided. So now we're simply going to roll down our master production schedule. We always go left to right. And so our first shipment of 100 shutters in week 4, our gross requirement is 100 shutters. You have no scheduled receipts and no projected on hand of the shutters. So your net requirements are 100 shutters. That means you need to have them arrive or be finished in week 4. And because it takes us 1 week to build them, if you need to ship them in week 4, you have to start that order in week 3. So you're going to start the order of shutters in week 3 to ship in week 4. Now, some companies might have finished goods units of these shutters already on hand. They might have some scheduled receipts, so they might already have open orders, or they might have some projected on hand. In this example, we do not, but companies many times will have finished goods sitting in inventory, so you would need to take that in consideration when you're doing your MRP netting. In this example, your net requirements equals your gross requirements. So now we're going to drop down to the frames and the wood sections, which are dependent on the shutters. Notice one thing here. You must start building the shutters in week 3. So the frames, when you drop them down, because you have to have the frames and the wood sections both completed on time to start the order for the shutters, you must have your gross requirements of shutters completed in week 3. So because the frames are 2 per every 1 shutter, you're going to take 100 multiplied by 2, and that gives you a gross requirement of 200. You have no scheduled receipts and no projected on hand. So therefore, you've got 200 as your net requirements for the frames. You need the frames in week 3, and they have a 2-week lead time. So your 200 pieces of the frames must be either made or bought starting in week 1. Okay, so you must start the order for the frames in week 1. They have a 2-week lead time, so they will arrive or can be completed in week 3. That matches your net requirements, which matches your gross requirements. So that is what you would do for the frames. Now we go down to the wood sections, which are 4 wood sections per 1 shutter. Your gross requirements are 100 shutters. So you're going to take 4 multiplied by 100, gives you a gross requirement of 400. Your scheduled receipt of 70 wood sections is scheduled to arrive in week 1. After it does physically arrive in week 1, it becomes projected on-hand inventory. It's now on hand. It's gone from being on order to arriving. So it's now here. So your 70 pieces is no longer an open order, it's arrived. So now you have 70 pieces on hand in week 1. You do not use them in week 1. So they sit in inventory in week 2 until they are consumed in week 3. So you need 400 shutters. You need 400 wood sections. You have 70 wood sections on hand. So your net requirements is 400 minus 70, which gives you 330. So your net requirements are 330, and they have a 1-week lead time offset. So your wood sections you will either make or buy starting in week 2, that's when you will release the order, to arrive in week 3. And that's how you do MRP processing on a lot-for-lot example. You have to keep in mind the lead time offsets. You always take into consideration the projected on-hand inventory or the scheduled receipts and net those out to get your net requirements. And you always go left to right because you want to consume any inventory that you have and make sure that you ship your order that's due to ship sooner for your earlier orders. So in this example, you have 70 wood sections on hand, and they will get allocated to the order of shutters that are supposed to ship in week 4 instead of being allocated to the order in week 8 of 150 shutters. So real quickly, let's not forget that we have another order to do. We have 150 shutters that are supposed to ship in week 8. So those 150 shutters, that's our gross requirements. We have no scheduled receipts. We have no projected on hand. So our gross requirements equals our net requirements. They have a 1-week lead time offset. So for them to ship in week 8, we need to release or order in week 7, and they will be done in week 8. To support the order of 150 shutters in week 7, we need 2 frames for every 1 shutter. So we need 300 frames to support the order of 150 shutters. We have no scheduled receipts, no projected on hand, so therefore our net requirements equal our gross requirements. And the frames have a 2-week lead time. So because we need them in week 7, the release will happen 2 weeks before that, which is week 5. And then last but not least is our wood sections. They are 4 wood sections for every 1 shutter. So to support your order of 150 shutters that is shipping in week 8, you've got a 1-week lead time offset for those shutters, which means we need all of our material to arrive in week 7. So 150 shutters multiplied by 4 wood sections gives you 600 gross requirements. You have no scheduled receipts, no projected on hand, so your net requirements also equals 600. They take 1 week to make or buy, so your planned order release will take place in week 6 so that they will be done in week 7. You can see that the 70 wood sections that arrived in week 1 were used on the first order that shipped in week 4 for 100 units of shutters. So for our second shipment, because there was no additional scheduled receipts, the net requirements matches the gross requirements, and there is no leftover inventory of either the wood sections or the frames. This will change in our next video when we go over lot sizes when we don't buy or make exactly what we need. If we have to buy more than we need, we're going to have leftover inventory. But lot for lot is very clean. You make or buy exactly what you need to support your orders.